Hello everybody, this is Janet20 and in this video I'll be discussing everything you need to know about pseudocode. Now this tutorial won't only apply to those studying for IGCSE, but it will also apply to those who are studying for the AS and A levels. So therefore this is a generalized explanation of what is pseudocode, what you need to know in order to ace every pseudocode question. So let's get straight into it. First of all, let's get to the definition and purpose of pseudocode. Pseudocode is just an alternative. In very simple terms, it's just another way of writing an algorithm. If you've heard the word algorithm for the first time, then basically it means a step of instructions to do any task. For example, if I say to write an algorithm of fetching some groceries from the supermarket, then it would be written in such a way that you go outside, you go to the supermarket, you fetch the given grocery items and you return back. These are a step of instructions that you have to follow in order to complete the given task. Similarly, pseudocode is just a simple method of showing an algorithm. It describes what the algorithm does by using English-like keywords that are very similar to those used in your high-level programming languages like C++, Python, JavaScript, etc. Now, any of the data items to be processed by the algorithm are going to be given meaningful names in the same way that variables and constants are given. But keeping that aside, let's first of all know the basic components. In order to know the basic components, we need to go over variables and constants, data types, arrays, inputs and outputs. These are like the basic building blocks that you have to know in order to do any of the complex stuff about pseudocode. Now, on my right hand side, I just have two panels over here. Throughout this whole tutorial, I'll be showing you these two panels. The first one is the console and the second one is the code editor. In the console, I will be showing you what kind of output the program will show you, because some of the components that we'll be using in pseudocode will give certain outputs. Therefore, all of those outputs or inputs will show up in the console. Whereas in the code editor, this will be the place where we do all the magic. All the code will be written in this code editor. Now, back to where we were. We're going to first of all go over variables and constants. What exactly is variable and what exactly is a constant? To first of all start writing a variable, you need to know about declaration and initialization. Declaration syntax looks something like this. You write in capital words declare, which is a keyword, followed with the variable name. Suppose I write the variable name as my var. Then you write a colon and then you write the data type. Now you don't need to worry, we have just introduced a ton of new stuff over here. When we have just written this line, we're basically telling our computer that hey, I need you to reserve some space in the computer. Suppose this is our computer. These are two places of memory or places where the data is stored. Now when this program runs, we have this myvar that is stored over here. Currently its value is 0. So it will store the value 0 over here. Now the computer also needs to know what kind of data are you storing. It just can't store the data without knowing what is its type. So we will now go over some of the basic types that are present in pseudocode. The basic types that you need to know are integer, boolean, character, string, and real. So we have integer, we have boolean, we have character, we have string, and we have real. These are some of the data types that you need to know for the IGCSE syllabus. There will be more data types for the A level, but that's none of our concern for now because we need to master these basic data types first. Integer, as we've already known, basically allows the variable to store only numbers without the fractional part. If you'll even try storing a fractional number like 5.5, it will basically cut off, or in other words, truncate all of the decimal points after the whole number. So we'll be just left with 5. Moving on to Boolean, a Boolean is a special kind of variable that can only hold two values, true or false. And this is again as well keywords, so they must be written in capital. These are used again and again in defining conditions. Then we have character or char. Character basically stores just a single letter. It is just like storing text in a variable, but you're only allowed to store a single letter. Then we have string. Think of string as a bunch of the char variables or the character variables grouped together. We have bunch of letters that are grouped together to form words, and that's from where we get the name string, a string of letters that is made together to form the text. Then we have real. Real is just another fancy name for having decimal values. You're going to store 5.5, 5.6. You can store those values in only a variable that has been initialized to be a real variable. So these are all of the data types. How we can declare and initialize each of the variables with these data types, I'll show you just right now. Previously, we just had written declare myvar, and I said that it can store integer. Well, it has stored the number. It has now made a place in the memory for holding integers. Well, now I want to give my own input or my own numbers to this variable. How do I do that? Well, that's very simple. On the very next line, you will write your variable name myvar followed with the assignment operator. Assignment operator is basically going to assign or give the value which is on its right hand side to whatever variable you're placing on the left hand side. In this case, we know we can only give integers. So let's suppose we store 10. Well, how does the computer interpret this piece of code? The best way of reading pseudocode is by going line by line. It sees the first line, that is declare myvar. Right. It stores a place in the memory for holding myvar. And then after that it reads the second line and it sees, okay, myvar has now been changed to hold the value of 10. So then it keeps the value 10 over here stored. We can also just write over here to visualize that the computer will now hold 10 in this place. So the computer will now hold 10 in this place for the duration of the program. All of the following lines of code will then, whenever they will access this myvar variable in the computer, they will know that this myvar variable is holding the value 10. Now if we change this piece of code over here, suppose I made myvar to be a data type of string. Well, we know string can hold text. Text must always be written between the double quotation marks. So over here we can put any kind of text. We can put, suppose, hello. Hello as an example. So we know that now we have changed the value of myvar to hello. That's again going to go into the computer and it's again going to look into the same memory place in the computer. And it will store in myvar the same value hello. Now whenever any next piece of code after this pieces of code will try accessing myvar, it will again get the value hello. And that's basically how variables work. If you're going to declare character, for that you need to use single quotation marks, and in that you can store single letters. For real, you can store any kind of decimal values. For booleans, you can keep it as true or false. Now, I just previously mentioned that some of the data types have default values. All of the data types that are being discussed for the IGCSE syllabus have default values. What do I mean by default values? Default value means that if I had stored this variable as an integer, the computer in that same place where the data of myvar is being kept, it will change it to 0. That is the default value during declaration. Because when you declare a variable, of course, it's not going to be kept empty. It's going to be kept with some sort of default or initial value. If you had changed this integer to be a boolean, by default, the computer will store in it false. And then the same case will be for real, but for real, we'll have 0.0 or 0.00. Depends on which language you're doing. For now in pseudocode it doesn't really matter because it's still the same thing. Whereas for character, it will have an empty character string. For string, it will have two of these quotation marks. You need to remember that these are also considered as a string. Empty space, or basically empty two quotation marks, also represent a string. It's just that it's empty. Well, moving on from here, we're going to look at now constants. Now constants are a little bit different from variables. Whenever you declare a constant, you must assign a value to it. It is generally good practice that if you are going to have a variable that will never change throughout the program, you could instead write it as a constant. Suppose I have in my variable a variable such as pi, because that's a very common constant. Now I know the value of pi is 3.14 for short. This won't change throughout the program. So for the sake of clarity and for the sake of good practice, you are going to assign a constant pi at the beginning. You can keep this to a decimal, 3.14. There is no need to give the data type in this case because the number has already been assigned in the start. The program or the computer will assume that it is a decimal from start. It is a real value from start because we have assigned a value to it. Now this can of course apply to any of the values or any of the data types. You can store any kind of constant. String constants of course also work. It's just that constants are values that cannot be changed throughout the program. Once you have declared it, you cannot access this place again. It's like the computer locks this piece of memory over here. Suppose we had stored 3.14 in this place. The computer then locks this place throughout the rest of the program and it won't allow it to write on it again. It won't allow it to modify it, but it will allow the program to read from it. The program is given access to read only from it, but the program cannot edit on it. That's basically the difference between the constants and variables. So you can modify variables, but you cannot modify constants once they are declared. Moving on, we have discussed data types. Now we're going to move on to arrays. Suppose I ask you to store the marks of students. Student 1 will have some sort of variable mark 1. If we assign some value to it like 50, now I want you to store this mark for 50 other students. So of course we can clearly see that the marks will become inefficient sooner. We will have 50 lines of code because we'll have to declare 50 variables and initialize 50 variables. And that's where arrays come in. Arrays are basically data types that allow you to store multiple values of the same data type. Suppose I want to store the total, I want to store marks of 50 students. I can store that in an array. Now don't think array is any complex word because it's literally just a fancy name for a list. And the declaration and initialization is very much similar. Suppose I declare an array over here, student marks. I give the colon as it is done with the other data types, except that after that, the data type is written in a bit of different manner. You first of all write array to tell the program that this is an array. After that followed with of. Oh yes, and we're missing one thing over here. Array, because it's a list, you need to define what is the length of that list. By default, it's a good practice to have the list's lower value, like first most value, to be of 0 or 1. It really doesn't matter if you're going to declare it 0 or 1. Followed with that a colon and then the maximum limit of the list. Suppose I said that the student marks will be of length 50. We're going to store 50 marks in it. So the maximum value which you need to store is 50, or in this case 49, because 0 is also being considered as a separate place in the array. You give its length from 0 to 49. With that you write of, and after this we're going to tell what is the data type that will be stored in this array. And we're going to keep over here integer. Now what happens back in the computer? Well, the computer takes that line of code and then it does something like this. Suppose these are all the memory places in our computer where it will hold data once the program is executed. These are all the places, and suppose I store 4 marks into it. By the way, Currently it's going to be empty. It's just going to initialize 49 different memory places that are in order, or in other words contiguous next to one another, and these will be reserved for the student marks. Currently it's going to be empty, including this first one. It will be empty. We'll just type a 0 over here. It will be empty. So how can you access and how can you edit in the student marks array? Well, you write student marks followed with the brackets, and then you're going to mention the index or position from 0 to 49. Where are you going to store the marks? If I said I'm going to store it on the third position, I write the third index over there, and then we put the assignment operator, that is again the arrow, followed with the value. Suppose we write 100. So what does the computer do? The computer again reads the program line by line. It reads the first line, it initializes 50 spaces. It reads the second line, and then it goes and it starts finding for the third position. First one is 0, second one is first, third one is second, and this fourth one is going to be considered as the third, because we're starting from a 0 index based list. If this would have been 1, this would have been the third position. So we know that this is the third position. What the computer does is that it puts a value in there. Simple as that. It puts a value in here, 100. And that's how arrays basically work. Of course, you can overwrite it as well. You can put another line over here, student marks, index 3 can be something like 50. It's going to change that value over there. So it's like you're declaring a bunch of variables, but they're all compacted together into a single list. That's the only difference. Moving on, we are going to have inputs and outputs. Inputs and outputs will be used throughout the programs in pseudocode. The way you write an input is by writing the input word followed with whatever thing you want to input from the user. Now, of course, input from the word itself makes sense that we are going to input something from outside the program. Now here's where the console comes into work. You first of all have to declare some sort of variable or some sort of basically place where you're going to store that input data. Suppose we are going to store it in my var. In my var, we're going to store something like string. So we're going to then take on the next line my var. Now how does the computer react to this? Well, it's simple. Let me just remove this. Now how does the computer react to this? Right, it reads the first line. It sees, okay, my var must be declared. It declares the my var variable. On the next line, it goes to the console, and over here it gives out a message to the user. Over here it's just going to ask the input value from the user, and you will see something like a cursor hovering. And that's basically the program prompting the user to input something. And then whatever the user inputs, suppose hello, and then hits enter, that hello value is taken back to the program and it is stored into my var. Right. Now I want to check, did we really store this value in the my var variable? And for that we do output. And output is used to basically output any kind of sentence, value, number, whatever you'd like. Suppose I give the input was followed with a comma. This is basically a different way of writing the sentences or the commands in output. You can output multiple things as long as you're putting a comma in between. So I put the output of the input was followed with a comma, and then I'm going to give another output that is my var. Now the program reads this line of code, it goes back over here, and then it gives the output over here, hello again. Because it took the input first of all and kept it in my var. The input was hello, and now my var has the value of hello. So then when we move on to the output line, it gives the output the input was along with the value that was stored in my var, which was the user's input. You can do the exact same thing with the arrays too. Remember what I had said. Suppose if I had something like student marks back over here again, let's just remove these lines. if I had something like input student marks, and suppose it had a length of 50, we're assuming it has a length of 50, and I asked from the user any input. Now whatever user inputs, it's going to go into this second position in this array, and when we output that array, we're going to get the output. Now you just can't output the whole array, you need to output it one by one. You need to access that specific position in the array. If I output the 1, it will be empty. Of course, by default it will be 0, because all of the arrays positions have default values of 0, as we had discussed before. But if you output the 2 or the second index item, it's going to give you that input back again. The same thing is with the arrays. And this basically covers up all of the basic components. Now we move on to the control structures. Now here's where things get a bit complex, but not that complex as a matter of fact. So why am I discussing control structures? Well, control structures are of many kinds in pseudocode. First of all, we'll go over sequence. Sequence is basically a group of statements that are going in order. So far, we have been discussing about variables, constants, arrays, inputs, outputs, and I have been mentioning again and again how the program reads the program from top to bottom, line by line. That's basically sequence in action. The program is reading every of the statements in a sequence. It's not jumbling it up and down. It's not starting from bottom to top, but it's going from the first line and it reads each line one by one separately. That is sequence already covered. Now we move on to selection, and selection is like adding branches to your program. If I want to do one output, if the input changes, that's what you can do with selection. With selection, you can create multiple branches for your code, multiple possibilities in your code. And here where conditions as well come. How do you do selection, you may ask? Well, over here we're going to introduce if statements. The general structure of if statements goes on something like this. You have the if keyword followed with a condition, and I'm going to just keep the condition an empty bracket over here, and I'm going to fill in the condition just later. If condition followed with then comes the else, then comes the end if. If is the start of the condition, and then basically checks the condition. If the condition you gave is true, it runs all the statements which are in this area. Otherwise, it runs all the statements which are in this area. Kind of self-explanatory, just because of the then and else words. Suppose I give over here a condition. A condition is basically an expression which can only evaluate to true or false. Suppose if I give over here something like, and we had declared a variable like age. Suppose age was a variable declared that holds integer values. And I said if age is greater than 10, then output, as we had previously mentioned, then output, you need to do some indentation first of all. Then you're going to output allowed or something like that. Otherwise, you're going to do the output. Otherwise, we'll give some other kind of output. Some other kind of output like not allowed. Now, how does the program interpret this? How do you read this condition? Well, you start just like the program starts. Start from the first line. If age is greater than 10, over here, this is a relational operator which I have used. This relational operator is just what you study in maths as well. Greater than, or lesser than, or equal to, or not equal to, which is with this kind of symbol, or greater than equal to, or less than equal to. So it's pretty much the same thing. So we check with the condition. If age is greater than 10, we read the first line. If it is greater than 10, then we output allowed. If this age is greater than 10 is not true, which means if it evaluates to false, the else part runs. And in the else part, you get the output not allowed. The entirety of the top then part is basically ignored. Vice versa for the case, if the then part runs, the entirety of the else part is ignored. Then the program which is end if, which means condition is over, we just get out of this condition. That is the basic kind of selection. What if I wanted to do more conditions? Well, that's very simple. You just write with the else and if. Else if, with the space or without space, it doesn't really matter. You may choose with space. Else if, and then after that you write your second condition. Age was lesser than 0. Obviously, this is not valid. So you could give something like not valid. But can you see the error in this program? After the condition, we need to mention the then keyword. The then keyword follows every condition. Similarly, the if keyword follows before every of the conditions. And you can see a kind of pattern that's following over here. It's a bit different when you're considering making an else if condition, because then in the end you need to actually write another end if. This is followed in the IGCSE syllabus, but it's not followed in the AS and A level syllabus. So the number of else if which you declare, that is the number of end ifs which you should also write in the end. If I didn't actually have this whole else if part, I wouldn't have to write this extra end if. Now of course I can write further conditions as well. I can also write an else part, but you need to remember that you can write as many else ifs you want, but you can only write one else. Similarly, you can just write one if, of course, that's the start of the statement. So that's why you can only write one else. I could only give something like this. Suppose if I had written over here else, output not valid, I cannot write a second else over here. That is the wrong syntax, the wrong if statement. It's not correct at all. Now this was the case with the conditions. What if you have a long list of conditions and for that you had specific values? Let's take a real life example. We suppose declare something like grade that's going to hold a character. Now we know the specific data that can be stored in the grade, and for this case we're going to use something called case. Case of followed with the variable on which you're going to do the check. We put over here grade, and then we of course write the closing statement, because this is the opening statement. For each of these opening statements we need to write a closing statement, and that is really simple. No need to even remember it, because it automatically makes sense that end case should be the thing to do over here. Case of grade, and then you have end case to denote that this is the end of the case. Now how do you write conditions in this? Well, for this you don't need to do any kind of comparison. You don't need to write anything like greater than, else than, or any kind of comparison. All you have to do is to just mention one of the values of grade. So I know one of the possibilities of grade is A. For this you write just one statement, and that's very important. In the case you just write one statement for each of the specific cases. This is known as a case. Suppose if a person gets A, we output excellent. We can write more cases as well. We can write something like if somebody gets an F. For this we can output something like try again. So how does the computer read this? Well, the computer of course starts with the first line, declare grade. It declares the grade variable. Then it starts with this first line, case of grade. So it now knows that we're going to start a case statement. It goes on to the next line and it checks the value of grade first of all, and it compares it with the first case. Suppose I had made grade as F. So it starts and it assigns grade the value of F. Then it goes over case of grade. It sees and then compares the value of grade that is stored with the first case. It doesn't match, it moves on to the next one. Just like in the if statement, it ignores the entire case. It moves on to the next case. It sees that the value is matching, so it runs the statement that is after the colon. Now there might be a case, or there might be a situation where the value doesn't match at all, because that is always a possibility. Well, in that case you write something like otherwise. Now otherwise doesn't follow with a colon. Otherwise is just like an alternative. Just like in the if statement we had if else after the then. This is the same case for the case statement. So we write otherwise followed with whatever statement you had to write. Output invalid. So if I had given something like Q, it will go line by line and compare each of the cases. All of these will be ignored because none of them match the current value of grade, that is Q. It goes on to this one and it outputs this. This one will always be outputted no matter what. But if any of the cases are matched above, this line will be ignored, and along with all of the other or the successive next cases. That was your basic cases done. And this basically concludes everything you need to know about the selection. Now we're going to move on to iteration. Iteration is like having multiple loops in your programs. Suppose I wanted to give an output of hello 10 times. So what's the best way to write this? Am I going to write 10 times output hello, 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 hello? That may be a possibility, but again, it is inefficient. So for that, we introduce the first kind of loop that we're going to use in our program. That is for loop. And the syntax goes something like this: for followed by the counter, or basically any name for the counter that is going to be used in the program. For now, I'll just keep it like this and I'll tell you in a minute how you can modify this. Counter, and then we give a range. This for loop is basically a count control loops. It runs a specific number of times. How do you know the number of times? You give it the range. We start from 0, followed the keyword 2, and then the end of the range. Suppose let's say 10, as we had mentioned. We go on to the next line and we write next, and then it's important you write the counter. Over here, we can then move our output statement. And now we have basically made the same program that we were trying to make before. What will show up in the console? In the console, the program will run somewhere like this. The first line of the program starts, and the program and the computer basically sees for counter, okay, how many times? From 0 to 10. Then it starts and it goes on to the next line. It sees output hello. Alright, it outputs the word hello. And then it goes on to this next line and it sees next counter. Now it makes sense from the statement itself over here that we need to go on to the next value of counter. What does the program do? The program goes all the way to the start of the for loop and it starts from that place again. Now here it's important. Previously the value of counter while we were looping from up to down was 0. This time it increases to +1. The computer then stores in its brain that the value of counter is now 1, and then it outputs hello again. So again on the console we see hello. This happens 10 times until when it does the next counter stuff again and it goes back to the start of the for counter loop. It again then checks with the range. Now suppose our counter had reached the value 10. It sees, alright, have I hit the max limit, which is 10? If it has hit, it just exits the loop. And there you go. It outputs hello 10 times and that ends the for loop. Well, what if we didn't know how many times we had to output hello? For that condition, we have two other kind of loops. That is the repeat loop and the while and while loop. Let's start with the while and the end while loop. These are called condition control loops because you basically never know how many times the loop will run or how many times you need to do some task. Suppose we had some boolean value over here. Boolean value like declare loop, and we give this the value boolean, and we assign it the value of true because by default it will be false. And we give that loop value over here. Now I know that the loop value is true. From the word itself we can understand that while loop, which means while this condition, and as I told you, a condition evaluates to true or false. A while loop is like a combination of a if condition and the for loop. So now again we think in the terms of if condition, right? The condition is true. So while the condition is true, which in this case is the loop, it is true, we run all the statements that are inside. And then there might be some kind of mechanism inside. Suppose a counter, let's just say a counter, and we give it a value of counter +1. What I've just done over here is assigning a value to the counter. So as you can see, I've just assigned a value to the counter, which means that every time the loop will run, it will increment the value of counter to counter plus 1. And if we basically run this program, it will run forever. And that's not what we want, because the program will never stop. You'll have to force the program to stop. So instead of this example, we can put a condition over here. Counter is lesser than 10. While counter is lesser than 10, suppose we had a counter integer declared above. Now the program runs with the counter value 0. Suppose we initialize it to 0. It then goes and then it increments the counter by plus 1. This keeps on happening until the condition gets false, which means until it gets greater than 10. And at that point, this loop ends. If the condition would have been already false, suppose if I had written -1. Now I had just said over here that the counter is initialized to 0. The condition has already been false. 0 is greater than -1. So the loop just ends. The program reads the first line and it says, okay, the condition is false. It just skips the whole next part. If the condition would have been true, it would have kept on looping this statement inside. But as the condition has already been terminated, as the condition has already been false, the whole program is terminated. This is an example of a precondition loop. But what about a post-condition loop, where we first of all run the statements and then we check the condition? This is useful for basically many examples. One of them is validation, which is discussed in further detail in one of my other videos. Repeat until, suppose counter was lesser than 10, or let's just take a real life example, until string, not until string, until suppose password is not equals to empty string. Of course, now we know that passwords cannot be empty, and suppose we take the input from the user of the password. Now this is an example of a repeat loop. The program starts with the first line repeat, and as there is no condition, it just moves on to the next line. It runs all the statement until it reaches the last line, until password is not equals to an empty string. It makes sense from this that until the password is not an empty string, the loop will keep on repeating. This is an example of where the post condition loops are useful. You obviously don't want to check the condition in the first place, because in the first place we'll be asking for the password for the first time. Obviously it will be empty. So we take the input of the password and then we check the condition. Both of them are basically condition control loops, and that basically ends everything you need to know about iteration as well. In the next video, I'll be discussing about functions and procedures and other common operations and best practices that you have to know about pseudocode. If you had enjoyed this video, make sure to like and subscribe. Thanks for watching. Goodbye.